Okay, in the next, let's adopt some more systematic approach. I kind of investigate and use a little bit patience to kind of list all relevant information that you can collect in like sensors or other kinds of pooling in an area even before some future election happens. So these are the general population information of the counties. There are a lot. The population of the people and the education, poverty, some medical issues, occupations of the residents, so on and so forth. And let's do some systematic building of lots of attributes. You may ask, how do you know we need to cut at maybe 6%? How we need to cut at this and there? Well, let's do some systematic way. I will use this quantile cart function provided by pandas. Let's have a look at what is the quantile cart. Over here, say if we use pandas qcart, pd.qcart, so we use this. Let's say for example, this is our old friend, at least bachelor's degree. We use this attribute to perform the qcart. Okay, and we can assign some value of carting, which is very similar, not very similar, which is the beginning of the values. Those concepts we have learned in the introductory to data analytics. So this is beginning. This is consider the different quantiles of the population and cut them into different bins. Let's see what we'll have. We'll have this number of the same number of the counties, which means it put one county into one quantile. It is to build a histogram, so there are 4 intervals. If the population with a bachelor's degree, the proportion is between 3% to 13.1%. This is one quantile, and this is another quantile, this is another quantile, this is another quantile. Okay. Well, this is not very convenient to read, so perhaps you can give it labels to label those different quantiles, which does not change the information, just the way you call them. Okay. So, okay, this county has the least proportion of people receiving higher degree of education, and some counties such as this one has some respectable portion of the population receives the bachelor's degree. And we do this for all those variables, which you can see we create a lot of attributes, which will create a lot of possibilities to split, to divide the population. Let's execute this. We create a lot of columns and get a lot of warnings. Don't worry about that. Let me delete this part. And here I also consider some vote info, but let's don't worry about this for now. I copied from above and the entropy computation and I reorganize that to remove some printing reporting functionalities, and I also copy the subpopulation computation, but this time we directly compute the information gain. Okay. Well, I moved from other source the construction of the decision trees. This is the hard part. I will invite you to watch the decision tree building tutorials, which we cover in the foundations of machine learning and in the early part of the course. Okay, so I will give you some introduction of the essential part. Well, the core part, it makes use of this information gain computation. Well, if you read it carefully, this piece of code corresponds exactly to the code that we have studied above, and it also makes use of the compute entropy, which we also discussed above. And here we don't worry about the predict. For now, we consider the fit part, and we have some bookkeeping. We will worry about this part later. And if you don't believe me, you can try to remove this part altogether, and you will encounter some weird errors when it comes to practical data. But the core part is here. Okay. It's basically just a bookkeeping thing. We consider the maximum possible information gain we can have by divide and conquer of the data. We divide the data using different case. By case, we mean these guys quantile attributes. Let's see. Later, I will use this data to represent to test the tree building, and let's see what's the case in this data. Copy and execute this, and have a look at the data.case. You will see that it will be the quantile attributes that we have investigated before. And if we check, maybe let's see, 2 of this. Okay, those are the 3,000 something counties, and these are keys. Note that you have less numbers of counties than before. That is because we have removed dropped some counties that with missing values. Okay, and the target is as before, whether the Republicans won in this particular county. So we will use this data to train this model, and this will come into this function as x, and we will for each possible k of x. That means we will for each possible value of these guys. Okay. And using that, we will compute the information gain. We will use this k, and in this data body, and consider the distribution of the target splitted using this k value, this particular attribute. We will compute information gain using this. Well, then this is just the bookkeeping. If the information gain is greater than the currently maximum one, we will keep this key as okay. We will split the data here using this key. Okay, and of course update our record of the maximum information gain. Okay, I think I've made an error here. Oh, what? I think I have used a different variable name. Okay, so after we have determined which is the maximum information gain to consider, we will take the subpopulation of the data and create children's for this node. So now at this node, for example, we have decided some attribute. According to that attribute, we will split the data into 4 quantiles. That is Q1, Q2, Q4. Okay. For example, if this attribute is the proportion of the population receives bachelor's degree, and this could be, well, the less people receiving bachelor's degree, the counties where less people receiving bachelor's degree, and this will be the counties where the most proportion of the population receives the bachelor's degree. Of course, that is given that at this step we have decided the bachelor's degree is the attribute that will give us the maximum information gain. Okay, and here will be the subpopulation with all the lower portion of the population receives the bachelor's degree, and we want to further investigate in this subpopulation how to split that more, or whether we can reach some kind of conclusion here. Okay, so that's the idea. And look at here, we will create the subpopulation, use children, and the children is in this data structure. It is just a collection of more tree nodes, so that the structure is recursive. It contains the object of the same kind of itself. So if you keep growing that this way, you will eventually have a tree structure. Okay. These are the children of this guy. These are the children of this guy. And these are the children of this guy. So you do the split and you feed the children of one child by another using the subpopulation of the data, and using the same way of finding the most promising attribute to split data, and then split data further and further. Okay, then we arrive at the header part of this. This is just some bookkeeping part, which means whether the subpopulation is small enough, it's better not to split anymore, or we have received some unanimous conclusion that all counties in this subpopulation will give you one same decisions that you do not need to do more subdivision. So that's the idea. That's the idea of constructing the decision trees. Okay. In the next video, we will try